Okay, so this is your lab number 3. Here we will do the Fourier analysis of the time domain signals and functions. So the pre-lab is the pre-lab is to be done in the MATLAB. Here we have some, if we have, suppose we have sine function. So you know that sine is some waveform like this. This is sinusoidal waveform. So if you want to take Fourier transform of sinusoidal function, this is a MATLAB built-in command Fourier. So we use it to take the Fourier transform. Okay, and SYMS is to define these variables A, omega naught, and T. So because MATLAB doesn't understand if we only simply we put some variable like x, y, it will not understand, it will give you error. So we have to define it with SYMS so that it will store these as symbols, okay, variables. So then similarly cosine, if you want to take cosine, Fourier transform of cosine functions, we just take Fourier of f, it will give us the Fourier transform of cosine function. Similarly, all of these, this has to be done in MATLAB. Next, in LabVIEW, how we can take Fourier transform of any sinusoidal, cosine, any function or signal. So we have to take this FFT analysis block, and then you can see that this is your time domain signal and this is the Fourier analysis of a time domain signal. So let's go to LabVIEW and check how we can make this. So here, so this sine wave generator, you can go here, you can just write wave generator, you can bring it here. And then from here, you can choose sine. Or if you want to directly take this, you will just go to signal processing, generation, and wave generator. So this is the same block. Okay, so here it has amplitude. You will right click and then you will bring from here amplitude. Then you will right click here, this is frequency. So you should see that where it is frequency, so you will just connect there, frequency, amplitude, so it is given you here. Then you will right click, okay. So then from here, this is sample rate, and here these are the samples, okay. Then you will connect here the FFT block. So you get this block from here, you go to analysis, then you go to communication, analog, okay, signal processing, you will go to measurement, and then FFT spectrum, okay. So this is the same block which is used here. Then we need this block, which is, if you go to here, data types, then waveform, and analog waveform, and then build waveform, okay. So all this information, how you bring these blocks, are given in experiment also. If you open lab experiment number 3 sheet, so if you go down, so here it's written how you bring these blocks, okay. So please see all the experiments, because they are helpful to understand how you will bring these blocks, and you should know the name of the blocks. So if you are not able to bring it from here, you can just go to LabVIEW and type here, but you should know the name. For example, pattern generator, like this. So you can directly bring it here, but you should know the name of the block so that you can search from here, okay. So, and please look here. So everything is written here, how you connect the blocks, what is any block is doing. So all the informations are written here, okay. Then okay, then you divide the number of samples with x. Why you divide it with x? Because you have from here frequency, okay. So this is frequency, so you divide it with time, so that you get a time domain waveform, okay. So from here it will go to time domain waveform, okay. And this graph will give you the Fourier transform. You can rename it also FFT, okay. So then the next step is go to panel view, and then you will write here amplitude and frequency, which I will give you the values, okay. For example, I say you write amplitude 2 and frequency 200, okay. Then you will run it, not 20, it's 200. So now you see with the frequency of 200, this is the time domain signal, and then you can see here if I decrease it. Okay. So if I decrease it to 300, so you can see that your frequency is at 200. So your frequency was 200. So Fourier analysis gives you all information in one spike. So here you have a big signal which has frequency 200, but in Fourier analysis, it is easy to understand what is the frequency of your signal. Okay. So then we can stop it from here. Then let's go to question number 2. Here, so here we are finding the Fourier transform of two different sinusoidal functions. So you have one sinusoidal function here with different amplitude, which I will provide you. Then this is the second wave time domain signal. And then here I added both of them here, and then here we take the Fourier transform of the sum of these two signals. Okay. So if you go to here, now this program is very simple. Here you will bring one wave generator. So you will go to analysis, signal processing, and you will go to pattern generator. Okay, from the pattern, if you click this block here and you go here, you can change it. Okay, so this is sine wave. Okay. Here I think this block is you are using wave generator. Okay, so then you put it here, and then you connect with this sample rate and samples. Okay, then this block, if I delete it from here, you will go to numeric. From here you will bring this plus. Now when you will connect it with this, it will automatically change it to this one. Okay, so you will and then you will add it and here. This is very simple. Now if you go to panel view, so always remember you have to bring graphs from panel view. Now only one graph is there which is giving the Fourier transform. So if I ask you to plot the signal 1, so this is signal 1, this is signal 2. So what you will do, you will go to panel view, you will bring a graph. Okay, so let's take these things here. Okay, now this is my signal 1. Okay, then take these things here. Now if I want to plot this signal also, what I have to do is I will go to panel again, I bring another graph too. Then I go to diagram view, you see that it's here. Now you can take this graph here, you can rename it also. Signal 1, and then there is another graph, we can put it here. So this will plot signal 2. Signal 2. Then also we can plot the time domain analysis of these two, addition of these two signals in time domain. So we can bring another graph. So let's say I can put it here for some time, and I can bring another graph here. Okay, so here I can just click this graph and put it here. So and then I can write it sum. So because this is sum of these two signals. So what I can let me put the amplitude here and the frequency of signal 1 here. Okay, and then frequency of signal 2 here and amplitude of signal 2 here. So this will make more easier now. Now, if I put amplitude, I will provide you the value of frequency and amplitude. Okay. So if amplitude 1, and let's say we can choose frequency of 10 is fine, and here we choose 2 and 20, and if we run it, so you see here. Now this is signal 1. Then this is signal 1, signal 2. Now the sum of these two signals is this. Okay. Now the frequency of first signal is 10, frequency of second signal is 20. Now you can see here, if you can clearly see it because my frequency is very low. Now you see my first signal frequency 10 is here, and then second signal frequency 20 20 is here. Okay, so this is the way to plot Fourier transform of time domain signals. Okay, so we can add here another signal. If I ask you, then you can just bring, or if I stop it from here, let me show you this. So here, for example, you have three signals, x1 with amplitude and frequency 10, x2 and x3. How you will bring x3? You will just go here, you will just maximize it here. You will just copy paste same block. Okay, so you will just copy paste. Now this is third signal, and you can okay. Okay, 1 minute. So you have to take this add again, and you just drag it down. Now it has three inputs. Okay, one input goes here, second input goes here, third input goes. Okay. We have to. We have to separately use, because it can try again. So it will not work like this. So we will bring another graph here. So this will come here, and then I will add it this one here. Okay. Now I will add this here. Now three different sinusoidal plots will come. So for this, I have to take the third one. So we don't have so much space for the third signal. What we can do is we can just give amplitude 3 and frequency 30 to it, and we can just see the sum and here. So if we run it, now you see the signal changed. The third signal, because we have added the third signal, and now we have three different frequencies: 10 for signal 1, 20 for signal 2, and 30 for signal 3. And then this is the sum of all of them. So this is the method to plot the Fourier transform of sinusoidal functions. So, okay, and then if I give you a table, you will write amplitude. For example, amplitude of first signal was 1 and frequency was 10. Second signal was 2 and third was 3 and it was 20 and it was 30. And then how much was the sum? Signal 1 plus signal 2 plus signal 3. So we can just see that it has different amplitude and frequency. So you can just add it, 3 plus 2 plus 1. So it will be 6. So then it will be 60. And then Fourier amplitude. So for the signal 1, the Fourier amplitude, you can write it from here. So it is 0, how much? 6, 7, 0.8, and it is almost 0.7 here. 0.7. Similarly, this is 1.4 and this is 2.1. So we can write these here, 0.7 and 1.4 and 2.1. So we can just add them here and then write the answer, and then Fourier frequency. So it was 10 and then 20 and then 30. And then here we can add them. Okay. So bandwidth is not related. So this is all about lab number 3. Okay.